the camera in it.
Yep.
How
You put that, it becomes that camera. Uh-huh.
then it should show what the light source, but upside down.
So if you look at the window, that shape, for example, if you look, will you see that shape in there upside down? Does it work?
Yeah.
You can make it do it? So is it, if people are gentle with it, would they be able to have a look if you passed it around? Or is it too fragile? She's not sure. She's really thinking about it. How do you look through it? Show how.
You would put a camera, point it.
You can put your eye, you should be able to see with your eye. It works well. But you have to look at it really bright, of course. Yeah. So James, did yours work? You can see, where does it show you? How's it work? Okay. Better when you soak it. Yeah. So then what happens is the light comes in here and then projects the image onto this little screen, right? And then, but the image is upside down. Right?
You away? Go back to sleep. Why?
That's what it is. It's that spot in the back.
Yeah, I
Sunday.
race
That.
that.
Full power.
Race snack.
Another kid broke
Race
his
night.
You don't go.
And right here.
Yeah, they just like, what?
Yeah, same scene, but so.
Actually, it has a match, the boss has a match squad.
And yesterday,
Works
after
better.
my family,
But that's crazy.
in my family, so at the rank I play at, there's a restaurant upstairs and stuff. And one of my friends wanted to sit at the table, we didn't let him because it wasn't my phone, so he punched me in the face. So I punched him back.
And you need to be in a darker room for it to work
Got one
really
that's
well,
close to-
but it will reflect the shape, like the shape of the light with the arc camera. And the arc window, we slide it back and forth.
That's not too.
It's really cool though. It's not just that. Did you program that putting in everything?
You knew that, yeah.
Very cool.
What? No, if you knew that, I knew you surprised.
Yeah, it's gotta get, the room itself is too bright, but if you're in a dark enough space, you should be able to make it.
Does it imprint it on the?
You know him just very.
It will, also doesn't look bright. It will imprint it, no, it won't make a permanent image there, but it will make it so that you can look in and see it. Where's your stuff? Where's your camera now? Did I take it? Oh. Hang on till I grade them off. These are cool.
It's worked before, we don't know it.
Yeah,
I see through it.
yeah, it's a little bright, so it really isn't working too well because it's all bright in here.
Oh, wow, that does work.
Yeah, it should be able to. So when you look at a bright light source like that window, it will take that light through that little pinhole aperture and it'll project the shape of that light, the image of that light, upside down onto the little
Try it.
this like screen here. Yeah, and you can see that, it does work. Your close-up vision's terrible, it doesn't work too well, but yeah. Yeah, it does work. You can,
Wow.
oh, Caitlin's works very well, you can very much see that.
Wait.
So if you look through Caitlin's at that window, you can see it, it's much bigger and it shows up pretty well. You can see the shape is upside down, you see it? If you look through there, you can see the shape of that window in there upside down.
How do you do it?
Just, almost just look straight on. Yeah, just put your eye with it. Should be able to see that light, the shape of that window, but it'll flip.
Seeing it.
Yeah. Kayla's is a little darker than James, so hers is
I
actually,
have black paper on the inside.
yeah, it's working a little better with the darkness. So like, look at the window. And you should be able to see the outside of the shape of that window, but
Oh,
you
yeah.
see it, but it's upside down. That's pretty cool. Isn't it neat?
Oh, wow, that was really cool.
I just stepped on the cable for a second, that's all. Okay. All right, crew, well, we will go ahead and start since everybody's here. I got one, I got two, these are great. Keep on coming. You get extra credit that way. I like when people get to build stuff. All right. I'm drinking iced tea out of my amazing mug with the caffeine molecule on it because why not?
I got that for you.
Mm-hmm. Yep. Xander, if my dad should appear again. Oh, no, sorry, Lucas, if my dad should appear again, I may need you to hop over because that's the only seat he can get out of comfortably, just so you know. I don't know if he will be back for class or if he's going to take a nap. He just kind of wandered out. So, alrighty then, let's do this. This is going to be a fun lesson today. Okay, there's going to be an activity smack in the middle of this lesson, and it should be fun. And I'm going to introduce you to two of science's most historical and amazing smackdowns. Good stuff. Good stuff. So static charge and static electricity. All right, so electric charge, the property that causes subatomic particles such as protons or electrons to attract and repel each other. So an excess or a shortage of what? Okay, Lucas.
Electron?
Yes, of electrons. It's going to produce a net charge. All right. Nobody here has done chemistry with me yet. Chemistry is next year. Here is your heads up on chemistry. Today is the 20th. How many days are left in this month? 9, because it's a leap year. Kind of a trick question. That means if you have not already re-enrolled for next year, you have 9 days where I'm still holding your spot. After that, it opens up to the world, and I've already got 4 or 5 people chomping at the bit. So that's great for us. That's really good for us. So anyway, if you want your spot, go home and be like, Mom, dude, take care of it. Most of you guys in here, I think, most of you, not all of you, but most of you in here, I think, have already re-enrolled, which is great. Okay. So chemistry. Does anybody remember what an ion is? Or anybody know what an ion is? Because you guys haven't done chemistry with me. So, do you know?
A particle with a positively or negative.
Yeah, exactly. An ion is a particle with a positive or negative charge. So basically, it's an atom that has either lost or gained electrons. If it loses electrons, is it going to become more positive or more negatively charged? Yes, because electrons are negative. So if it loses negative, it's going to become more positively charged. And if it gains electrons, it's obviously going to be more negatively charged, right? Okay, so keep that in mind because that will pop back up in the context of all of this. Okay, so you have laws of attraction and repulsion. Oh, repulsion. So the force of attraction or repulsion between electrically charged objects, like charges do what? Okay, Yusuf.
Repel and opposite charges.
Yes.
Attract.
Yeah, like charges repel, opposite charges attract. When they say opposites attract, they don't just mean romantically, they mean like for real. So if you have 2 positives, they're going to repel each other. 2 negatives are going to repel each other, but a positive and a negative are going to attract. That's why when you had those magnets, some of y'all were playing with the magnets at the counter rather than going over there. You could use one magnet to push another magnet along because it's repelling. Can anybody think of a form of travel that uses that concept? Ooh, yes, Liam.
Maglev train.
Maglev train. Have you ever been on a maglev train? Anybody in here ever been on a maglev? Hey, Drew, you've been on a maglev. Okay.
They're insanely fast.
Yeah, here's the thing about maglev. It's basically hovering, right? You're using magnets to move the train forward and to keep it off the track. It floats above the track, the whole train. So what then are we reducing? If we're hovering above, friction. Friction is way down on those things and they go crazy fast. I think we were going 286 kilometers per hour at one point.
It was ridiculous, like we were booking. It's wild,
Maybe they could like put magnets underneath roads so then like people could start inventing magnetic cars.
That would be very nice.
77 miles per
That'd be very interesting,
maybe-
Well, my dad went on my little train, and Lucky,
Yeah,
his friend was there, but I didn't go.
well, they're fun. If you ever get a chance to ride a maglev, yes, Drew.
I don't think they really exist yet, they're still theoretical, but ion engines that are
Mhm.
for spaceships.
Yeah, there's all kinds of stuff that people are working on right now technologically that is super duper fascinating. And we're going to talk about one of these big tech guys in a little bit towards the end of the lesson. All right, electric fields. The effect of an electric charge has on other charges in the field around it is your electric field. Okay, so the strength of an electric field depends on the amount of what that produces the field. Okay, Colin?
Charge.
Yeah, the amount of charge that produces the field and the Chloe? And the distance or length it travels. Yes. Okay. So oh, wait, real quick though. Yeah, I know, right? I know. Some of these AI images were the absolute best. So you can see here, you got your positive and your negatively charged, link, link. Whereas these guys, this shows you what it would actually look like if you diagrammed those magnets pushing each other away. All right. So we have this dude. I love this. This is super fun.
Oh.
All right. So somebody tell me, what is the law of conservation of charge? Who knows that one? Chloe.
The total charge is isolated.
Yeah, the total charge of an isolated system is constant. What do we mean by isolated system? What do we mean there? Yusuf,
One that is separated from other systems.
yeah, well, it's another word for yeah. Yeah, you go. Yeah, it's like a closed system, right? Basically, you don't have anything else interfering with it. Charge can be transferred in different ways. So what is it when you transfer a charge by rubbing electrons off one item to another, Drew?
Got
Ooh, yeah, but
Friction?
friction's the one I'm looking for. Yeah, okay. So yes, does cause static charge. Okay, and friction. All right, now I want to show you something. Oops, there we go. So where did I put it? Oh, I put it away in here. This is cool. This is, okay, see what I have here? All right, I got a little jar and I got a little wire, and this is an enameled copper wire, okay? Which means that it has a coating on the outside of it that is going to be non-conductive. And then the inside of it is very conductive because it's just copper. So all you do if you want to expose an end of it is you just take some sandpaper and you rub off that enamel, all right? And then I've made it big and flat here. I've actually made like a coil and squashed it. And I put some aluminum on the end. And then inside I have two little tiny like leaves of aluminum foil that are back to back. Now, if I okay, what happens if I rub this on my head?
If the electrons move from your head to the.
Right, my electrons that are in my hair are gonna come out of my hair because now I'm using friction. All right, and they're gonna rub off onto this balloon. Now, woo! We know it's working, right?
It's always fun.
That's what you want to look for. All right, what do we hypothesize is gonna, you've seen it. What do you hypothesize is gonna happen if I get the balloon close to this little
Great
sensor?
hypothesis,
What's your hypothesis?
that the two pieces of tinfoil are gonna spread apart like this.
Why would they do that?
This is my hypothesis.
But why?
And
Why would they do
I think we're
that?
gonna see sparks.
You think we're gonna see sparks? All right, watch very carefully.
I'll look at that on the right. It's crazy.
You couldn't explain why, so you won't right.
What is happening?
Spark and.
Wait, I don't see anything.
There's no sparks, but
There's.
can you see them moving apart?
Yeah,
Move it over here.
it also rotates.
What?
It's not working that well.
Because I moved it, I touched it with my other hand. Hang on. I'm not even gonna touch it, just getting close.
What's that sound?
That sound is electrons jumping.
This-
You hear it?
Okay.
Yeah, little popping sound. So what's happening? Somebody tell me, why is this doing this?
The
electrons are.
I would say it's creating two light poles that's causing them to repel.
Yes, so what it's doing is, The electrons in my hair are coming up here. I got new shampoo that's really great, new conditioner. It's very lightweight. I love it, but it makes my hair super staticky because it's not greasy. It's very light. So woo, see that? Oh my word. So yeah.
I should start combing my hair with.
Yeah, that's what I was thinking.
So what happens is I don't even have to touch this. The electrons are literally I'm eating my hair. They're literally, let me show this on the video one time because they're watching that. But they're literally jumping off of the, here we go. They're jumping off the balloon, jumping through the air, and they're getting to that little sensor. And when they get to that sensor, they're forcing those two little things apart because they are like charges. I'll put it out right there and it can stay there till after class. So, yes.
And it says that the total amount of charge in an isolated system is constant, but like, on the scale of the whole universe, this is similar to the conservation of momentum. Like there is a set amount of charge in the universe. You can't create it. Or
yes. Okay, there you go. Okay, good point. It's always moving around from atom to atom, from location to location. Yes.
Why is there like hundreds of scales in the picture?
Those are wires, and I don't know why it's like that because that's what AI did for me. All right, so what do we call, what's another one for conduction here? It's electrons or charges that are passing and flowing from one object to another. Caitlin?
Charging contact.
Yeah, contact or conduction. So if it's contact, if I were to touch that balloon directly to that little sensor thing, that little paddle on top, then that would be directly moving from one to the other, as opposed to like kind of rubbing. We had them rub off. All right, we rubbed them off and then we got them close enough that they could jump. So what is it called when they're jumping, when they're transferring? Milo. There you go, induction. So what we saw there is we saw friction at work, induction when we got close to the top of the little sensor and they jumped, and then it was conduction that went down the wire and caused the two pieces of foil to move apart. So we saw all three ways that charges can transfer in that one little thing. Pretty cool, right? And that's super easy. You can make those at home. They're fun. So static discharge, by the way, one of the images it created for this was the cutest freaking image, but
looks like
it
lightning.
yeah, it didn't quite work. I had to use this one instead, but it was a baby mouse with like giant, soft, fuzzy slippers. It was so cute. So anyway, static discharge occurs when what? What are we looking for? Caitlin, do you know?
A pathway through which charges can move.
Yes, when you create a pathway through which charges can move. You ever walking around in your socks on your carpet and you reach for your doorknob and it goes zap, right? Okay, that's exactly why, because now you've created a pathway for those charges to move and you feel them when they hit you, right?
Did you know that the when that happens, it might be as much as like 11,000 volts of electricity?
I don't know how much. Wow, okay.
I feel like that would kill you.
No, it can be like, it can be a lot of volts, but it can be a lot of electricity, it just doesn't feel like.
Well, you're also grounded, right? So you're standing, so things flowing through you are not the same as things flowing at you, right? A little different there.
If you were like hovering and like the electricity didn't have anywhere to go, like through your feet into the ground, if it was just going into you, then yeah, 11,000.
That's bad. You would be very much fried. Okay. Electric current and Ohm's law. All right. So hold up a second. These two dudes here, Edison and Tesla. All right. We're going to come back to Edison and Tesla and we're going to do an Edison and Tesla game. I actually have two Edison and Tesla games, but we're going to do one of them today. And, if I don't know if anybody,
That's awesome.
nobody probably picked up on this, but this whole dress is covered in Tesla patents.
Oh, that's
Cool, right? All right. So, and it might
the mustache.
It might change your opinions on Edison and Tesla a bit. All right. So electric current is what we call the continuous flow of charge. So there's two types of current. One, you've only got charge flowing one way. So that one is called what? Chloe. Direct current. Direct current. And then what is it called when it goes reversing direction back and forth? James, that's your alternating current. All right. Now keep in mind, this is the thing to keep in mind. Edison was a huge proponent of AC/DC. Do we know? You're going to know by the end of this lesson. Okay, we're going to come back to them. All right. Conductors and insulators. All right. A material through which electricity can easily flow this is an easy one. Caitlin,
Conductor.
that's a conductor. And a material that is going to resist the flow of electricity is, all right, Jordan.
Electrical insulator.
Insulator. Okay, so metals like copper and silver are good conductors. Things like wood, plastic, rubber, that should say are good electrical insulators. All right, now, why are metals better conductors than other things? Okay, it has to do with the way the electrons are organized within that atom. So before this class wraps up, the tail end, the Q4 of this class has some light chemistry, which is leading us into next year, which is great. And we will talk a little bit about atomic structure, and we'll talk more about it next year in chemistry. But when you have, there's called valence electrons, they say they're shells, like they are in these like groups that surround, kind of like an everlasting gobstopper. If you've ever seen one of those cut in half, it's just layers and layers and layers, right? And electrons are like that. And you've probably seen models, like a Bohr model is really common. It's the one with the circle and a series of circles like a bullseye, right? And then it has little dots on it to show where electrons are and whatever. That's just how we conceptualize them. And even the shells are not gobstopper-ish in the way that they're not uniform. They're different shapes. Some of them are more like a barbell. It's really kind of, it's almost impossible to model an an atom correctly in such a way that you could like see it, because the electrons are moving constantly within a cloud around the outside of the nucleus of that atom. But if you have a particular element that has lots of electrons that are able to be snatched away because they're on that outside edge, those are going to be your conductors, because those electrons are not as tightly bound to that atom as ones where you've got the exact, they're in nice and tight. And also when we talk about ions, right? Ions have extra. If you have a negative ion, do you know what a negative ion is called? Do you know?
Electron.
A negative ion is called an anion, and a positive ion is called a cation, right? We'll talk about how cations are positively adorable, and you'll never forget it again. Little cat, there's a little graphic, it'll stick with you forever. So yeah, so your anions have this extra electrons there, and they're not as tightly bound. So this is why salt water, you have sodium chloride in it, and the sodium chloride is going to have lots of free electron, well, not free, but loose electrons. So that's why when you put salt into water, it's going to conduct better than if it's just water. All right. So resistors. So what are the things that resist? Go ahead.
Was Nikola Tesla born in Germany or something?
Serbia, I believe. Yeah. Mm-hmm.
So
Yes.
the brownie point in the binder, it spells resistance REISTSN.
Oh, there's an extra one in there. Okay, there you go. All right, good one.
Resistance.
So resistors are opposed to the flow of electrical charges in materials. So in a way, they're insulating, sort of. Okay. So materials, there are three things that are going to affect its ability to resist. What three things are we looking for? Caitlin.
Thickness, length, and temperature.
Yes, thickness, length, and temperature are all going to affect how well something conducts electricity. So what do we call a material that has almost no resistance when it's cooled? Yes, Liam.
Superconductor.
A superconductor. Okay, so you have conductors, superconductors. You also have semiconductors, which you've probably heard of too, right? And then you have resistors. If you are to look at somebody over there, who said the word breadboard earlier? Somebody said, was it you, Jordan?
Yeah.
Okay, what's a breadboard? Describe a breadboard.
It has like
Like, what would you say?
Grid
Uh-huh.
of holes where you can like mess with the electricity.
The
And
components,
I
yeah.
think
Mhm.
vertically all the holes are connected. like,
Yes,
vertically,
there you go. Mhm.
But horizontally they're not.
There you go. Yeah, okay, so it's a component you can use when you're building electronics. All right. You ever taken something electronic apart and you see that green, like the motherboard in there, it's green usually. And sometimes when I was little, I thought they looked like city streets with buildings and like oil tankers and stuff on them because they have little tall things everywhere. And then you can see where things connect, look like little roads. Those look like little towns to me when I was tiny because my dad had a lot of that stuff and I always thought it was really neat. Well, if you ever see these guys, right, you've probably seen them. They look like little pills or capsules. And they're on those electrical components. These are resistors. And remember a couple weeks ago, we talked about one of the jobs that you can't have if you have certain types of color blindness is an electrician. You see why? Like this stuff right here, this tells an electrician what kind of resistor they're using, how much resistance it's going to create, all these colors. So that's why, like, if you have color blindness to these certain colors, it's not going to be great for you to do electrical work. You're going to have some problems, right? Yes.
All the bomb diffusion.
Yeah. Oh yeah. Oh yeah. I want my bomb diffuser to have excellent color vision. That's just me. I want my bomb diffuser to have excellent vision all around. Can we just be real good? All right. So let's talk about voltage. So in order for a charge to flow in a conducting wire, the wire must be connected in what? How do we connect them? Chloe? In a loop. Yep. So, sorry, I didn't mean to hit that one. That includes a source of electrical energy. So you guys who were playing over here with the snap circuits, if you didn't have a loop, a complete circuit, it didn't work, right? You had to have it go all the way around. And next week or the week after, I have a handout you're going to do in class that shows a circuit. It has little light bulbs on it, and it tells you what's lit up, what's burned out, and you have to determine which light bulbs are going to light, which ones are not going to light, right? It's kind of fun to do. All right, so this one's already there. So it's potential difference. That's the difference in electrical potential energy between two places in an electrical field. You can think of voltage as pressure. Okay, it's very similar to like pressure within a hose. Okay, so how much difference is there between the potential energy in two places? So think of it like you've got almost like a hose with a nozzle in it, right? Like if you have the water turned on really, really hard and there's a lot of pressure, that's like high voltage. And then if you were to release it, that voltage would flow, right? Same idea. So what's the measure? Caitlin.
Voltage.
Measured in volts. What do we measure in volts? Do you know? She's looking. James, do you know? Current. Well, voltage. Sorry, you were right. Voltage is right. So I don't know what I was thinking. My brain died for a minute. It does that. So voltage is is the measure of potential difference, and the unit is volt. Okay. So we're going to talk about where that unit comes from in a second, and it's actually kind of cool. So what's a device that converts chemical energy into electrical energy? Everybody over at that table was using them. What was that, Jordan?
Battery.
Those are batteries. Okay. So batteries are converting chemical energy into electrical energy. All right. Now, this is going to bring us to today's first great smackdown in science. This is one of my favorite stories. Okay. We have this dude named Luigi Galvani. Where do you suppose he lives with a name like Galvani?
Italy.
Yeah, he's Italian, right? So he's born in September of 1737. So is there a United States yet?
No.
Nope. All right. And he died in 1798. All right. This dude, he looks very serious, doesn't he, with his little powdered wig?
Not really.
So Galvani was an Italian physician, biologist, and philosopher, because of course, if you're smart, you are a philosopher in history. You have to tell everybody what you think and why you think it, because that's just what you do.
He's mildly surprised.
Oh, he has reason to be surprised. All right. So once, while experimenting with some disembodied frog legs,
What?
okay.
Nice.
Yeah.
I didn't want to.
Disembodied frog legs. All right. His assistant charged a metal dissecting tool with static electricity from a Leyden jar and touched it to the frog's legs. Now, a Leyden jar has it's got like brushes or something. I can't remember exactly how it works, but it creates static electricity, just like I was rubbing on my hair and we got the little, little zap, zap, same thing. It creates that. All right. So he put a metal device to it.
His assistant?
His assistant. Yes, he has assistants.
Well,
So
yeah,
keep in mind, he's a physician and a biologist too. So he's really into anatomy. He's chopping up frog legs. All right. And I just have to say, I've done some very similar experiments in college. If you become a biology major, you will do very similar stuff to this. Now, We can use just legs, like his were disembodied legs, but I'll tell you now, so you are not surprised when you walk into a college biology lab, especially neuroscience lab. So if you want to keep a frog's nervous system intact enough to react to things, but you don't want the frog alive anymore, I'm gonna tell you how this works. Y'all are gonna freak out. So you take your little frog, and usually the frogs that are used in science labs are genus and species Rhanus pippins. They're like these little spotted leopard frogs is what they call them. They breed easy, they keep easy, you don't have, they're real easy. So you take the little frog and you hold it in your hand, and you take a pair of scissors and you jam it in its mouth and you cut the top of its head off. Okay, first off, that's like, oh, I never could do that part. I was like, that's just one step too far. And I love dissecting things, but that's just, because it goes, right? Because you cut its little head off. All right. Then what you can see is you basically cut through the top of its skull. So most of its brain is now gone. And you take a long skewer, metal skewer, and you do what's called pithing. Yep. You run it real quick like this down its spinal cord. So it goes from the brain through the hollow of its spinal cord, and it makes mashed potatoes of anything there that would make the frog feel anything anymore. And now it's the top of its head is laying on your lab desk. It's real fun. Okay. And then you can do the type of thing that Galvani was doing. All right. But Galvani just whacked the legs off. All right. So what do you suppose is going to happen when this man takes this assistant of his, charges this little metal instrument, and then touches it to the legs?
He actually like jumps.
Yeah, well, yeah, they jumped all right. Okay. So now you got legs going, woo! All right. So this guy is like, oh, eureka. And he
Probably freaked out a lot.
got very fascinated now with the whole concept of bioelectricity. All right. It kind of looked like this, his diagrams. You can see a little disembodied frog legs over here with the.
They're not supposed to be that big. Those
Yeah, it's not
like
scale,
so
clearly.
manually.
There's so much frog legs. It's clearly not to scale, but you see what he's getting at, right?
Imagine if it was to scale.
And this machine with the crank, this is the Leyden jar where you'd be getting your electric charge off of. So crank, 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 touch the metal with little hand B there, and then come over here and touch the frog legs, and woohoo, they jump. All right, so, all right, this is fascinating for this man. So he got so curious that he started putting frog legs outside and running wires to them, like just kind of through the air. All right. Now, this was after Ben Franklin did the kite and the key experiment. Okay. You know, where he put the key on the kite string and lightning came through, and oh, look at that. All right. Ben Franklin did not discover electricity, despite what they told me in kindergarten. Okay. Can you imagine this dude living next door to you? You walk by.
I was just thinking that.
Right.
Using the neighbors.
Probably. So you're strolling along, you know, and this stuff's in the backyard. So yeah.
Our legs?
Well, you're about to find out some stuff.
Whoa.
Find out.
So then things with this man got really, really weird. All right, and here's what I mean by really, really weird. So you got to picture this. All right. You are strolling past Galvani's home. This is Galvani's actual house. It did not have that air conditioning unit on the roof, which was too difficult to edit out, but we'll take away the street and the cars because that's kind of weird. So it would have looked like so. And you were just strolling along, looking like that.
To his house.
Yeah, okay, you're his neighbor. So, you know, you're probably wearing your little terrible leather shoes and your terrible wool clothes because that's what we're dealing with here. And so anyway, you're strolling past Galvani's lovely home, and you notice his beautiful wrought iron fence. He's got one of those nice wrought iron fences that runs around the house. Real nice, right? All right. And it's a cloudy day, and storms, potential skies, and then you see this. Yeah, okay. Dude hung frog legs on his fence.
Delicious.
Yeah, right. So you're minding your own. You're going down to the market to get some potatoes for dinner, and your neighbor's got disembodied frog legs hanging them on his fence like this.
With
big
the
were
neural
frogs?
system
How big were the
intact.
frogs? How big were the frogs he used?
I have no idea what kind of. I don't know where he bred
How big were the
these.
frogs you used?
I don't know. If you stretch them, you know, stretch their arms out, they're probably about that size. We used them for all kinds of things because you can use them also for embryology research, because frog embryos develop externally, right? So you like, you know, you can watch a tadpole form, you can actually watch it. So the way, oh, I'll tell you how you do that. Well, that's real fun. So the female frog gets to live. The male frog does not get to live. You pump the female frogs full of hormones that make them ovulate, and they produce tons of eggs. And you fold her little legs up by her sides like this, and like James just said, you just kind of squeeze them like you're squeezing a toothpaste tube, and all these eggs squirt into your petri dish. But then you gotta kill the male frog, and you gotta take his testes out, and you gotta chop them up. All you boys are like, holy crap, chop in a little dish.
Oh, I feel that.
With some like homogenizing solution.
Oh, no.
Right. And then you take it, suck it up in your pipette, and you drop it on the eggs, and you can watch them fertilize. So if you're ever walking past a pond and you see frog eggs, if all the little black dots are pointing straight up like eyeballs looking at the sky, they are fertilized eggs. If they're not all looking the same direction, they're not fertilized. But when they get fertilized, they whoop, and they rotate up. So you can actually sit there and watch. And all these little eggs are turning, and you're like, babies, right? And then you can experiment on those embryos because they're external. Yeah.
But that is, we have to cut them if we are doing it, but how do they do it naturally?
Oh, frogs, naturally they mate. But he will come by and release, because it's external, she will lay her eggs, and then he will release his sperm on the eggs or near the eggs, and that's enough to. Yes, James.
They do talk with each other.
Yeah.
Like
Yep. Catches it on the way out. Good job. Yep. And you can't make the male frog do that. So you got to kill him and take his parts out. Hey, so
Chop them up and.
back to our friend Galvani. All right. So you're seeing this, and this is real life. Like, this is what's going on as you're walking past. This is your trip to church or to the market. Can you imagine? Like, I've had weird neighbors in my life, but never this. Okay, so yeah, exactly.
And these frog legs jumping around.
Oh yeah. So he saw this phenomenon as a work of biological organs, and he thought he had discovered something called animal electricity. So he's making a delineation between animal electricity, natural electricity, which is coming in the form of lightning, and what he was calling artificial electricity, which was basically static that the lake jar would produce. Oh, we're getting there. All right, so he thought that this was some body fluid that's like generated in the brain, and it's in this state of disequilibrium. And he thought, hey, I just reanimated a frog corpse. Wonder what else I can reanimate.
Oh, no.
Okay, all right. So what it actually discovered was that a frog's nervous system could transport electric charges, and when in contact with two pieces of charged metal, you got a circuit. Okay. Whatever hook the frog legs were hanging on would be your other piece of metal that when he's touching the little device to it. All right, now, he knew that metals transmitted this mysterious substance called electricity, but it became kind of obvious to him, that you have animal electricity, and it was generated in the tissues of the frog. It flows around through that metal skewer, activates the frog's muscles. All right, I'm trying to figure something out here, because why the heck are the frog legs jumping? This is really weird. So you can imagine, like, if it's stormy outside and you've got a lot of electricity, like free electricity in the air, like sometimes people in storms will say their hair kind of stands up, you know, because there's a lot of electrons floating around. Okay, so all those are getting into the fence, and you got the frog legs like whoop, on the fence. All right, it's crazy.
Crowd shooting, but
It's crazy. So he distinguished it, like I said, from what he called artificial electricity, which is your static, and then natural electricity, which is lightning. And he thought of it as a fluid secreted by the brain, and proposed that the flow of this fluid through nerves activated muscles. Okay, this is the first guy to ever make any kind of correlation between like nervous system and electricity. Your nervous system is like all electricity. That's how it works.
was that actually like a good guess?
Well, he's getting somewhere. Okay. Now, along with our friend Galvani, got this landmark discovery, like I was just saying, it's changing the way we understand the nervous system. Now, he has this nephew named Giovanni Aldini. All right. He looks a little sour, but this dude, okay. All right. So he was his uncle's greatest supporter, but he was also a very showy fellow. He loved the drama. So he traveled all over Europe, quote unquote, reanimating the corpses of animals. And I'm not just talking frogs. I'm talking,
I should have.
yeah, you guessed that right, people.
I guess that.
Okay,
Wow.
so
Wow.
here's a bull.
Oh.
We got Aldini here, trying to reanimate this bull with his head chopped off. Okay. Now, this is the kind of thing, you know, today when we want to be entertained, you know, you scroll through Instagram and you watch videos of people doing wild things. Okay, people used to come to the town square, can't even talk, town square, and watch these people do this crazy crap, right? Okay, so imagine you're standing in the town square and they've got like a headless bull and they're like making this leg jerk and you're like, oh my God, it's the coolest thing I've ever seen. Because you would have been at the time, you would have thought that.
Someone calls you like a witch and she's
Mhm.
all the time with torches and pictures.
So this process of quote unquote reanimating corpses was called galvanizing a corpse
I
from
wonder why.
Galvani. All right. So rather than dragging a Leyden jar around, because it's a big machine, Aldini traveled around with this thing called a voltaic pile, which is really like the first really functional battery. Okay. And his most famous demonstration happened in London on January 18th, 1803. Okay. Put yourself in 1803. Now, by now, Galvani's dead, right? Galvani died in the 1790s. So he's done. He's been gone 10 years or whatever. And his nephew's out. I shall reanimate dead things. Watch. Okay. Now, this gets a little wild. So you have a 26-year-old man, George Foster. He was accused of murdering his wife and daughter by drowning.
Oh, no.
And he was hanged that day in London. All right. Accused of, this is the 1803. Goodness knows if this man really did it because it's 1803.
No.
And yeah, if they're like, you did it, then you did it. And there's no appeal. You're getting hanged, right? That's the way it works. So dude was hanged. All right. Now, he was immediately transported to the Royal College of Surgeons, where before a big old audience, Aldini ran electrodes from his voltaic pile and attached them to Foster's corpse in various locations. You know what? Do you know what the British people call an operating room? They don't use that
An
term.
operating theater.
Theater. Yeah, that's why. Because everybody's there for the show. So it's been an operating theater since forever. So now they still call it an operating theater. They'll even say a doctor's in theater at the moment. They don't mean he's like, you know, working on somebody. All right. So he attached electrodes to his jaw and to his ear, and he got this like grisly one-sided grimace. You know, everybody's like, wow, this guy's dead and his face is moving. Okay, we're getting real weird. He made an eye open up and the crowd's like, this is the coolest thing I've ever seen.
Wait, when you hang, they cut off your head, right? How
No, they don't cut your head off. Here's another scientific thing. So hangings,
Talk about hanging.
if they're done correct, if you can kill somebody correctly, I'm not gonna use the word correctly, efficiently. If you hang someone efficiently, there is math involved with the rope, the elasticity of the rope, the length of the rope, the length of the drop, and that person's weight. Ideally, so as not to cause this person more torture, when their body falls, there should be enough force in the fall that it causes an internal decapitation, which is basically like a severing of your spinal cord inside your neck, where your neck and head come together. So it pops, your head stays on, but not on the inside, right? So that's the aim of a quote unquote good executioner.
You have to ask that.
The bad ones are the ones that they don't calculate properly. So people strangle to death, which is slow and obviously horrible, and everybody watching is horrified. Incidentally, women, girls, and teenage boys were the ones who strangled most often because somebody did the math wrong. They weighed less, they were smaller, and they sat there and dangled and struggled, and it was horrid. Whereas if you did it right, you had a big old fat dude, big old man, you throw him up there, he's snap, he's gone.
So if you do it correctly, the only thing that's holding set on is the skin. and stuff.
Yeah, muscle, skin, all that, but
Yeah.
the bones to a degree, but not entirely. Mostly your muscle, skin, tendons, yeah.
they slowed down chopping people's heads off
Mm-hmm.
because they thought it was a more humane way, but at one execution, the executioner held
Mhm.
off head, and someone from the crowd yelled his name, and he looked at them.
Yeah, yeah. Yeah,
And
Anne
he, like,
Boleyn is one. Anne Boleyn was one of Henry VIII's wives, and he was often his wives because they kept giving him girl daughters and he wanted boys, as if that's her fault at all. It's entirely on him, but hey, he didn't know. So he kept finding reasons to get rid of this wife, and Anne Boleyn is one. When Anne Boleyn was beheaded, like, and that's at Tower of London, but like her mouth continued to move the whole time. So anyway, this dude is dead. Like, he's legitimately dead, but his tissues still have enough, his tissues have not started to, decay or degenerate anyway. So they're still functional to a degree. So obviously you got an eye moving, amazing. So now his aim really, he wasn't just some macabre, creepy dude. He actually was trying to figure out, how do you go about saving a person that's undergone trauma and restart the heart? They'd figured out that you could restart a heart with electricity, or they hypothesized it.
But they
So-
can't do that if his head is severed from.
Well, yeah, but you're not gonna, like, it. He's experimenting on somebody who's already dead to find ways. Even if the heart pumps, that he's still dead because his brain's disconnected. But if you figured out, if I do A, B, and C, I can get this heart pumping again. I'll try that on somebody whose head's not been snatched off, and let's see if that works, right? That's what he's aiming at. So it's actually the genesis of defibrillators and AEDs. Everybody seen AEDs before? Like, most public buildings have them, and they are, if you've seen like the TV shows and the movies where they rub the pads together and they go clear and they shock somebody, that's what these do, but they're completely automated. So basically, like, you turn the box on and a voice will tell you, put this here, put that there, stand back, and it'll tell you, and then it'll shock the person. So they're really great because you don't have to know how to do it, except know how to run, turn the machine on, open it up. And they're pretty, yeah. So this is the kind of thing he'd been seeing. All right, this is real interesting. Got his little hand there in a bowl of probably brine, salt water.
Is he a bodybuilder?
So maybe he probably worked a lot in the field. Nobody sat on their butts in 1803, I don't think, unless they were like real wealthy. So back in 1803, he's just fiddling around. He hadn't quite figured it out yet. He's fiddling. So he kept fiddling around with Foster's corpse, just fiddling, somebody's dead son, brother, friend, just fiddling. That's all good. So he moved an electrode to the bottom of this man's spine, and he sat up on the table in front of everybody. And these comments in here, like, this is a cartoon from the actual event, like a newspaper cartoon, but it's hilarious. Had I not been born insensible to fear, now should I be most horribly afraid? Hence horrible shadow, unreal mockery. It's great. Like, this is great stuff, right? And look, little demons. Whoop, you got little demons from hell here. There, we've lost him after all. See, they're bringing him to life again. Okay, not really, not quite bringing him to life again, but fascinating. It even says a galvanized corpse. All right.
So weird.
Yeah, real freaky. So does the idea of a scientist, maybe a little crazy one, reanimating a human corpse sound like a familiar story? Yes, it sure does. Yeah. Sounds very familiar.
Everyone knows who he is.
So would you suppose then that Aldini got this idea of reanimating bodies with electricity from Mary Shelley, who wrote Frankenstein?
Oh.
Or, what do you think? You think,
The other way around.
you think it was the other way around?
Nah.
You're right. It was the other way around. 1818, 15 years after George Foster sat up after he died, Mary Shelley writes a book about a scientist using electricity,
Maybe it was
put dead body parts together and make a monster.
maybe it was totally unrelated and they just had
I think there's very little chance she didn't know about this, because this was big news, man. Dead dude sitting up in the operating theater is pretty darn cool news. Like, I'd be into that. What? Tell me how that happened. That's wild. All right, now we have this very solemn looking fellow here. Now, Galvani and Aldini were not universally celebrated. Galvani had a professional nemesis, and this man's name was Alessandro Volta. He was also an Italian dude. All right.
Too many Italians.
There's a lot of Italians messing with electricity. So Volta is another Italian scientist. He believed Galvani was wrong about how electricity was generated, stored, and transported. And he believed that metals were all that was required, and that electricity was electricity, not animal, artificial, or natural. It's just electricity is electricity. And he's the one who came up with the word galvanize, but he said it with an eye roll. Oh yeah, galvanizing people. Like he's the one that came up with that word. And so, of course, Galvani and Aldini were like, well, let's run with that. Let's coin that. That's cool. We have our own word now, even though this guy was being very sarcastic when he said it. So Volta could reproduce Galvani's results, but figured Galvani was wrong about the how and why of his experiments. And he was right. So Volta endeavored to create a device, a non-living thing that could do what Galvani claimed bodies could do. So what he did is he built a stack of alternating discs of copper and zinc, and he separated them with thick paper discs that were soaked in like a salt water. Okay.
What gave him the idea to do that?
Because he believed that metal was the only thing needed. And
those two specifically.
Well, we'll look at that. I don't know if it's this lesson or next lesson, but these are metals that are also they're very conductive, right?
How do you know that?
Well, because he knew you could pass electricity through them. So he figured if you could pass electricity from one to the other, and then here's your salts, you got some ions in there, all right? So this big sandwich stack, this big inedible sandwich stack became the first battery capable of continuous electrical current. Now, we already talked about that battery. Do you remember what it was called? Voltaic pile. And then who used it? Galvani's nephew. So, okay, thank you for inventing the thing that proves me wrong, but we're just going to use it to try and keep proving ourselves right because it's more convenient than hauling around a Leyden jar. Thank you. Right? Okay, so that's what Galvani's nephew Aldini was using for all his galvanization experiments. So, yep, thanks, Alessandro. Good job. Yeah, you can look depressed when you stare at that voltaic pile because, man, you just fed your professional nemesis a tool he could use. Oh, boy. So I love this. Here's your Luigi Galvani over here. The nerve and muscle generates its own electricity. Electricity merely excites the tissue. I invented a battery to prove it, but I can cut a nerve. I can cut a nerve to a muscle and the leg contracts. That's because the muscle and the nerve are just two different materials like zinc and copper in my battery. Wait, what if I connect two legs together? Okay, because that's the kind of stuff he was doing. Crazy stuff. So in the end, they were both right about some things, both wrong about some things. What they didn't understand was the function of electrolytes, which are at work in both the battery and all the animal experience. So electrolytes are things like, you get your sodium flowing around and like, when you drink your Gatorade, it says it has electrolytes. Basically what it has are things that have a lot of loose electrons in them. And so when you drink them and your body has all that extra loose electron stuff, it's able to communicate more efficiently. So it will help your nervous system make your muscles move faster, better, more efficiently. So same thing was going on when all those little soaked paper discs. They just didn't know it. So here's the legacy of this great smackdown in science. We now have batteries, a much better understanding of neuroscience, defibrillators, EKGs, EEGs, the term volt, which is the unit for electromotive force, measures how much pressure there is in an electrical circuit. The higher the voltage, the more electrical current. And then the word galvanize, which actually has two meanings, like a literal one and then like a more sort of a literary meaning. So it's to shock or excite someone into action. You could say like, the news of that car accident galvanized the community into creating a better intersection.
Or you could do what Galvani actually did.
Yeah, not doing that. And to galvanize metal is to coat it with iron or steel, to coat iron or steel with a protective layer of zinc. Galvanized metal is real popular with that whole like Magnolia Home Cotton Blossom urban farmhouse thing where you see the metal that kind of looks hammered or uneven on the outside, like buckets and stuff. That's galvanized metal, right? All right, so that was one smackdown. We're gonna do another one in a minute. Ohm's law. What's Ohm's law? Who can tell me Ohm's law? Okay, Yusuf.
The voltage in the voltage in a circuit equals, is this basically like a equation? The voltage in a circuit equals the product of current and resistance.
Yeah. So the voltage in a circuit equals the product of the current and the resistance. So you have a little triangle again. Remember these back in first quarter when we did all these? There's another little triangle. All right. So increasing the voltage increases what? You increase voltage, Chloe?
Current.
Yep. And keeping the same voltage and increasing the resistance decreases the current. Okay. So this is a great little cartoon. If you can kind of commit this one to memory, it'll really help you. So volt, we said, is pressure, right? And it's trying to push the amp, which is, we'll get to amps later, but that's basically your current, through a resistor. And your ohm is this little guy with a little R, he's the resistor. He's like tightening the hose, like you can't fit through, all right? And we'll come back to that too.
Triangle them.
So AC versus DC, remember these guys.
How could I forget?
Back to them now, as promised. So here is our our second great smackdown in science. Okay, Nikola Tesla and Thomas Edison.
ACDC.
I am going to hand everybody some little cards, all right? And what you're gonna do is, you're gonna get your packet of cards. You're not gonna open them till I say so. All right, you're gonna have the length of one AC/DC song to Google some of these crazy facts about either inventor, all right? And then you have the length of a second AC/DC song to sort them into fact or fiction. So
Oh,
don't
gosh.
pick until you've received your little packet. All right.
Oh, yeah, Google them.
Yeah. Okay. So don't peek yet. Hold it. Don't peek inside. Don't open it up. When I say so, you're gonna open it up and you're gonna have facts and fictions in here.
And we gotta see which one's a fact and which one's fiction.
Now you can tell there are 6 total fiction and I'll fix this second, and 10 total facts, right? 6 fictions, 10 facts. You're gonna have the length of one AC/DC song to Google. Right? And see if you can find any of this information. And then you're gonna have a second AC/DC song to do the sorting. You'll think. So we're gonna, for real. Hold on. Why are you being weird? Don't do that. No, not now.
Hey, you're open.
Hold on. Did I step on it wrong? That's important. We can't lose this, not right now. Yeah. Hold on a second. Don't know what happened here. Oh, here we go. All right. So while this song plays, this is your Google time. And then when this song is over, you're going to have to stop.
I can't Google.
Alright,
Wait, what you?
Oh, if you don't have Google, you can Google with your neighbor.
So confused.
You're going to Google, you're going to open your packet and there will be facts. Okay, you're gonna, and fictions in there. You're going to open your packet when I say go. And you're going to start Googling what's in there. If you've got your phone with you, if you don't, get with somebody who does.
Yes, that was a yes, you got to go phone stack.
Well, you can Google too. I have some others that are more a guess, but these are Google. Okay, are you ready?
Yeah, let's go.
Set, go,
Google.
and stop. Okay, no more Googling. Now you're gonna get to sort. All right, phones down. If you had one. Now you're gonna sort. You have one more song to do your sorting as fact or fiction. Are you ready?
I've already sorted.
You already sorted? Okay, some people are still sorting. Okay, ready? I'll give you the length of one song for those who haven't.
Hey, we're not supposed to be sorting?
No, you can sort. Set and go.
That's what we were doing last.
Oops, sorry. Yeah, go for it. If you've already, so since he's not here, I'll tell the story at his expense, but we had the Live at Abingdon DVD and Cole loved it as a toddler, loved it. And there's one part in one of the songs when Angus Young drops his guitar and he goes like this at the crowd, and these little double horns, right? And he thought that was funny. So we have a real good friend at church who's a priest, and we're like, you should do that to Father Joe sometime. He'll think that's funny because he likes AC/DC. Well, the next time Cole saw Father Joe happened to be when he went up to get his blessing at communion, and he was like 3. And he walks up and he's kneeling at the altar rail. Father Joe comes by to give him his little blessing because he wasn't taking communion yet. He was still little. He's kneeling at the altar rail, and Father Joe comes up and he goes,
Oh,
and
no.
then he fully vested one. Like, turn around, like, I can't. He was laughing so hard. And like, everybody's like, what happened? He's cracking up. So later he asked him, will you be my confirmation sponsor? We've been friends, met through a lot. So Joe's like, yes, of course. But that was hilarious. Made devil horns at the priest at the communion rail, you know, because that's how we roll in this family. All right, so let's see how you did. Your facts are 2, 3, 5, 6, 8, 10, 11, 14, 15, and 16.
Dang it.
And your fictions are 1, 4, 7, 9, 12, and
I only
13.
got 10 and 12 wrong.
What?
No?
Wait, so Edison,
Oh.
Edison didn't electrocute a bear?
Not a bear.
That seems like something he would do.
We're gonna talk about what he did electrocute.
Okay. So I
Yeah.
had 3 facts.
So I got
Yes,
2,
sir.
3, I got 2, 3, 5, 6, 8.
I'm wearing the
I
Tesla
got
hat.
2, 3,
Tesla hat was in
8,
black. Look at
10
that.
for fact, and I don't know for picture.
I only got 10 and 12
So
wrong.
9.
I did pretty good.
10 and 12 wrong. False.
4.
Yep.
Did I get 4?
500? Oh, no.
16 is fact.
11.
16 is fat. Patented inventions.
1, 4, 7, 9.
Oh no, 16 and.
Oh, but he
yeah,
didn't
16
keep
and
all
fact.
of his.
Google told me
Not
that
12,
Tesla had like
Yeah.
100 patents.
So,
Apparently not.
16 and 10.
yeah. All right, so put them back in your envelopes, and actually here you can pass this around, and you can drop your tax eviction envelopes inside of here. Watch them down here. Drop that and pass it around.
It says he has 1,000.
I don't know. I will have to double check that, but that's this resource I had these answers, so they may not be absolutely accurate, but they're what I had. All right, so let's talk about him a bit. So here is little Edison as a boy. Ain't he cute?
Yeah.
All right, and this is the earthquake machine. Who made the earthquake machine? Okay, there it is. Obviously it worked. That's a heck of an earthquake. And that's this as well. Here's Clarence Dally. Who's he? Do we know who Clarence Dally is? Anybody want to guess who Clarence Dally is?
The guy who Edison electrocuted.
He is the first man executed in the electric chair. Clarence Dally. This dude. Sorry, dude. I'm not even sure what he did. It's going around somewhere. I think it's on the back table. This is Edison's vote recorder. And this is Topsy. Oh, he's looking it up. Yeah, what did he do? I forget. It was murder of some kind, but I don't remember what specifically. I did look it up, but I don't remember.
Yes.
Alexa, what was Clarence Dally's crime?
Clarence Dallas was convicted of criminal mischief for damaging
No, that's
property,
not him.
including vandalism,
Wrong guy.
graffiti,
Yo,
and arson.
Alexa,
In a
stop. Not Dallas. Dude. Not criminal mischief. If they're gonna electrocute you, it's gonna be worse than that. Okay, who's Topsy? Anybody know who Topsy is? So Edison did not electrocute a bear, but
No.
okay. Yes. We'll come back to
I now
that.
hate everything about Edison.
Oh, we'll come back to that. So fascinating stories in history. Oh, look at this poor horse standing here with electrodes and then a hammer. We're gonna hit this metal hammer to, oh, I wonder what's gonna happen to this poor horse.
Take one down.
Yeah, I would think so. Here's your guy. First execution, AC power. Who invented AC power? Who's the AC guy? Tesla's AC, Edison is DC. What's in your house, AC or DC?
Both.
What's in the wall outlet?
DC.
DC. Battery is AC. What happened when somebody stuck those two batteries over there together? Yeah, they started to get real hot. Okay. Edison, in an attempt to make, so at the time Tesla was working for Westinghouse, okay? Westinghouse was promoting AC power. Edison was promoting DC power. He's using AC power to electrocute people and elephants. Why would Edison do that?
To make people think that his is better and AC was dangerous.
Yeah. Look at what happens with AC power. It just killed an elephant. You don't want that. That's not what you want. You want my stuff. You want DC power. AC is bad. These two men went back and forth and back and forth and back and forth. Tesla's workshop burned down at one point after he left Westinghouse. Westinghouse basically gave him like a big check to fix something. Like, if you can figure out how to make this work, here's a big cut of money. All right. And when Tesla left them and started his own lab, he had this massive workshop, and it mysteriously caught fire.
Probably Edison.
People today still blame Edison for that. They still suspect he was involved. There's no proof of it, but people suspect it. Had Tesla's workshop not burned, we would have a whole different set of stuff today. He was working on the X-rays ahead of Röntgen. All kinds of stuff he was doing, way ahead of other people who now have credit for those things. So when you talk about him getting stuff patented, that's a real smart move after it's all burned down. You know, well, shoot, if I hadn't patented it, if I had patented it, then I would have rights to it and say it was definitely mine. But if you invent something and you haven't gotten to the phase of having it patented and it burns up and suddenly somebody else is like, look what I invented. Well, guess what? You're out of luck, right? You've put all that time, effort into development and it's gone. So Edison says, and this is Clarence Daly. This is actually Clarence Daly, poor Clarence Daly sitting in the chair. The most suitable apparatus for the purpose is that class of dynamo electric machinery, which employs intermittent currents. The most effective are these is known as alternating machines, manufactured principally in this country by Westinghouse. So there's your alternating. He's like, oh, look what happens. You get zapped. So they would have done better with an axe, was Westinghouse's commentary on this execution. They would have done better with an axe. Like, it was not pleasant. Topsy. Okay, this is Topsy. Topsy was a circus elephant who had killed a man, okay? She got real mad. I don't know what her problem was. She got real mad and she killed a man. So
something bad too.
Quite possibly. So she was going to get executed as her penance, and it was done publicly by Edison's people. Let's shock this. Yep. Right. Now I will warn you. It was filmed. It is on YouTube, and it has even been like remastered, so it's clearer and better quality elephant execution. If you go looking, you will find it. Even if you're not trying to find it, you will find it. And if you don't want to watch a big old chill elephant go from being chill to like, and I mean, like, there's smoke, it's horrible. Like, if you don't want to see that, don't go looking for it, because it's legitimately out there. Like, I've seen it. I'm like, whoa. Yeah. Yeah, it's really bad video, which is why it's now been remastered, so we can watch her die better. Now we can watch her die better. Let's just hear it.
The Topsy elephant was so horrible that he got that his public execution just got immortalized in YouTube.
It says Tops, not Tops.
Well, her name is Topsy. That was they were nicknaming her there, making it sound cool for the newspaper. Tops. No, it's not that. Tops was put in chains by the trainer, Emery, as penance for her offense for killing some guy, which I'm sure she didn't know was wrong. This is actually like the very beginning of the electrocution. That's smoke. That's not like bad photography. That's actual smoke coming from her feet. So even if you don't mean to find it, you will find it. You have now been forewarned. R.I.P. Topsy. That's real sad. Very sad. Poor Topsy. So here's our man Edison.
Stop looking smug. You killed an elephant.
And this can explain Edison Westinghouse.
Thomas Edison. And there are certainly few inventors who courted controversy more often. Edison is credited with helping pioneer the use of electricity in everyday life, from the light bulb to the phonograph, as well as developing direct current in electrical devices. The latter, amazingly, was the source of one of the fiercest and dirtiest business competitions in history in what was dubbed the current wars. As America began to adapt to electricity, one of two types of current, alternating current or direct currents, needed to be adopted. It wouldn't be logical to have both, and Thomas Edison, who pioneered direct current, knew that. So did his rivals, George Westinghouse and Nikola Tesla, who were team alternating current. They began a race to see which current would become accepted by the public, netting their promoter a huge increase in public profile and profits. Due to the nature of the men involved, particularly Edison, this was not an example of good sportsmanship and friendly competition. Although not as instantly recognizable of a name as Edison and Tesla, George Westinghouse played a major role in how Americans use electricity today. He came from a military background, and his first big invention was the railroad air brake, which became compulsory a couple of decades after it was introduced. His experience with air brakes would later influence his interest in electricity, as he imported AC generators from Europe and perfected the designs of AC generators and transformers. The seeds of the current wars in America had been planted. As the name suggests, direct current runs in a single direction, while alternating current reverses direction dozens of times a second. Edison's conviction in DC was due to its superiority over AC when constructing motors. AC, however, had a huge advantage. It could stretch over much longer distances. AC seemed like the superior current to many, so Edison felt he had to go on the offensive.
Should you choose Westinghouse, then yes, there is a possibility
Yes,
it
it's
could
on.
put in jeopardy the lives of 28 million people.
Edison focused on painting AC and its high voltages as dangerous to consumers. Right, should any AC system
This
be
is from a
installed,
movie,
by force
these clips.
in 6 months.
What?
Edison decided to
Okay.
demonstrate it by helping to invent the electric chair using Westinghouse's AC. Dogs and horses were electrocuted first, and in 1890, the first prison inmate was killed brutally as the initial bolts didn't kill him. The most famous animal electrocution, however, was not Edison's fault, at least not directly. Topsy the elephant has become a symbol of Edison's determination to win the current wars, no matter the cost. The story typically goes that Edison electrocuted an innocent elephant in front of the public as a dramatic demonstration of AC's danger, but this is not entirely true. By 1903, Topsy had killed 3 men, including one man she hit after he burned a trunk with a lit cigar. Orders were given saying Topsy was to be destroyed. Animal rights groups thought that hanging was inhumane, and it was suggested that the newly introduced method of death by electrocution be implemented.
Great
A
question.
Brooklyn electrical company, bearing Edison's name, handled the voltage. A grizzly bear was filmed using another Edison invention, but the man himself was not present and likely completely unaware of the killing of Topsy. The two men's approaches to the current wars were largely defined by what they thought was most important about their inventions. Thomas Edison had a user-first philosophy, while Westinghouse looked at his inventions from an industry and infrastructure perspective. It was this mindset that would eventually help him win the current wars, as AC required fewer relay stations and other physical infrastructure than his rival system. When Tesla succeeded in developing an AC motor with Westinghouse, DC's days were numbered. Westinghouse was chosen to light the Chicago World's Columbian Exposition in 1893, signaling an end to the current wars and a victory for alternating current.
Thomas Alva Edison is a charlatan, praised on the fears of the common man because I have a better system.
AC is still used today around the world, while DC is mostly reserved for batteries. It wasn't all bad for Edison, however, as he would continue to make some other massively influential inventions. Westinghouse would suffer from financial crises around the turn of the century and die with no connections to any of his businesses. Check out one of our newest videos right here. Plus, even more grunge videos about history's most important figures.
So those clips are from a movie called
And hit
The Current War. And it came out, I think, 2 years ago. And I have yet to watch that movie. I really want to. It's on my bucket list of movies to watch. It came out 2017. I take it back a little further ago. It is rated PG-13. I'm not sure what for exactly. But it's got in it, just so you know, Benedict Cumberbatch, Oliver Powell, Sophia Ali, Tuppence Middleton, Tom Holland. Yep.
Tom Holland, you gotta watch it.
The whole room went, oh, Spider-Man's on the TV. I like that. The whole group of you. Okay. So now we have Elon Musk, who's the owner and or founder of PayPal, SpaceX, Neuralink, The Boring Company, Twitter, Solar City, and Tesla. Yeah.
Drug addict.
Now that's the tunneling company that he's making. Yeah. X, now it's X. All right. So I'm asking, on the topic of Edison and Tesla, what do you think he's gonna say? Who was the better role model? What do you think, James?
Edison.
Wait a minute, ask James. Wait. You think he's gonna say Tesla? Okay.
Because he owns a company.
Because he owns a company named Tesla. What do you think, Liam?
Edison, because I looked at the title of the video.
Edison looked at the title of the video. Yep, that's right there. That ruins it. So wait a minute, let me ask you this then. Hang on. Why do you suppose, since we see the title, why do you suppose he is gonna say Edison is a better role model than Tesla. What do you think?
It just said at the end of the other video, Edison didn't go bankrupt before he died.
That's a good one. Edison did not go bankrupt. Okay, what do you think?
I thought Tesla would win because his literal company is Tesla.
It's true. It is literally
Probably
Tesla.
Rename it as Edison.
Literal company Tesla. James, what do you think?
I think that because Tesla uses battery powered cars,
There you go. Yeah, yep. Emily, do you have an opinion? Why do you think he's gonna like Edison? We see that he's gonna like Edison because the video title popped up. Why do you think he would say that?
I don't know.
Think about what kind of a guy he is. What does he do? Look at all the companies he owns. All right. So listen to his answer because it's very interesting. It's probably not what you'd expect from a man who owns a company called Tesla.
As far as role models, I think, it's always some of the obvious role models. I think Edison was certainly a role model. Probably one of the biggest role models. Yeah, Eric Bookstone, absolutely. It's an interesting contrast, like Edison versus Tesla. It's interesting, the car company is called Tesla. And the reason it's called Tesla is because you use an 18 induction motor, which is an architecture that Tesla developed. And the guy probably deserves a little more play than he gets in current society. But on balance, I'm a bigger fan of Edison than Tesla. Because Edison brought his stuff to market and made those inventions acceptable to the world, whereas Tesla didn't really do that. He'd certainly be a big one.
Where's he from?
South Africa. So that's what's interesting. So he's a bigger fan of Edison, not for what he invented, but for how he marketed what he invented. So if you think about Elon Musk as a businessman, that makes perfect sense. The man didn't invent an electric car, but he sure made it more accessible to the public, right?
I was kind of right.
Kind of right. Yeah. It's interesting. Like you would totally think, well, obviously he must love Tesla. He named a whole company after it.
He didn't name it. It's not his company. He had most of the share of it.
Yeah, wait, yeah. Well, he's got a lot going on, right? Dude has kids with weird names that are like letters and numbers and stuff. Yeah. Everything is X. He likes X. What's his kid's got a weird name. It's like,
That weird.
what is it?
Xavier, I think.
Yeah, but it's like X
He's from
something.
South Africa.
What's funny is some reporter asked him once something about his kid and it's like a number and a,
actually,
look it up.
that name his kid.
huh?
It actually wasn't him that named his kid. He said it was actually his wife.
His wife, yeah.
His then wife came up with the name. It was him that added the -12 at the end.
That's the -12. That's what it is. Yeah. Yeah. So his kids are named.
His -12 was the.
He has 11 children.
Oh my gosh.
Yeah.
What do you want to name your child? 350 others.
And they are.
Want to name it?
He didn't have
others.
a name.
Okay, he has
No, I'm taking the baby.
Mechanicus, Griffin, Vivian, Kai, Saxon, Damien, and X dash whatevers. And yeah, so they all have these like, there it is. There's XAE and there's X hyphen Roman numeral 12, XII. And some interviewer asked him about A12, how's A12 doing? And he's like, yeah, and he's like, what? The plane? What? And she's like, no, your kid. He's like, oh, because apparently he doesn't call them whatever he's named them, which is bizarre, but the names are just straight up bizarre, but whatever. But it makes good sense because this man is like he is the marketer, right? He's making electric vehicles accessible, and now he's making space travel more and more accessible, and it won't be long before you can like do a space vacation, and that's going to be him. So it makes sense that he likes Edison. But Edison's one of those people that we've propped up as like this great American hero, and I'm not saying he wasn't. He did some fabulous things, but at the same time, he did some very questionable things. Very questionable things. Yeah.
Alex and Jack are actually going to be this space vacation in 8 days.
Oh yeah? That's what they want, huh? A space vacation? I would love to do it. It'd make me sick, I'm sure. All right, so we have one more little activity that we'll do one round of. Okay? So here's how it's going to work. this is a stack of Edison versus Tesla cards. All right, this is our second great smackdown in science. So, oh, we already talked to you, Elon. Go ahead, dude. All right, so this is your Edison versus Tesla stack of cards. I'm gonna start it over there and we'll go Asher, Drew, we'll loop the table, we'll come back to Emily. You're gonna read the card and give everybody a second to try and guess an answer, and then you'll flip it, and on the back side is the answer. There's a lot of cards here, so we'll just do one loop around. So I'll do the first one, and then I'll pass it to Asher. So the first question is, what was Edison's first invention? Anybody want to guess? Light bulb, you want to guess?
Telegram?
It's actually the global electric stock ticker.
What is a stock?
Hey, yeah. All right. He's got a who said it. All right, so he's gonna give you a quote.
You're having way too much fun.
Wait a minute, listen.
Most certainly, some plants are not impacted, but others are, and among these, there must exist life under all conditions and phases of development.
Edison or Tesla? What do you think?
Tesla.
Edison. All right, pass that one on to Drew.
Actually, it was Nikola Tesla.
It was Tesla. All right, there we go. Okay.
It said it on the other thing we did. Right. It said
Who's that? For all the years of experimenting and research, I've ever once made a discovery. I start where the last man left off. All my work was deductive, and the results I achieved were those of invention, pure and simple.
Edison or Tesla?
That sounds like an Edison thing.
Yeah, but
Well, that's the answer.
Edison.
Edison. All right. Just flip that one around. Pass them over to James.
No,
All right.
That's it.
Yes. What was Edison's first job?
Wait. What? Say it again.
What was Edison's first job?
Oh.
Worming
Wheels.
A telegram writer.
He was a paper boy on a train.
No, because he saved the kid from crashing. His paper.
He was also a paper boy.
Yeah, and then his dad was so happy that he hired him as a telegram writer. I think I know that.
It's someone with relatives.
So newspapers. Someone wasn't selling.
Telegraph operating.
There you go.
Someone was selling newspapers on a train. Was that not?
It was you.
That is true. But
wait, what?
What?
Our entire mass communication system is based on whose invention?
Ah.
Tesla. Elon Musk.
Tesla.
There you go. All right, Ridley.
No. Tesla said to Edison, "So confess to your debts and let the whole world know."
True, false?
You read the answer?
Yeah, that's just the whole thing.
Oh, okay. Flip over and find another one then.
Oh, that was the question, because the answer is most of Edison's inventions were either stolen or improved versions of other inventions, and people had no idea.
Ah, there you go. All right, Milo.
He received a patent for vertical takeoff and landing aircraft.
Ooh.
Hear any of that? I didn't hear it.
Received a patent for vertical takeoff and landing aircraft.
That's Edison.
Tesla or Edison?
I don't know. Probably.
it is that.
It was Tesla. Okay. Here, pass them over to Lucas, and then we'll keep the go around. Okay. There you go.
He made a motion picture of cats boxing.
Tesla. No.
Edison.
It's the Edison.
That sounds like Edison.
What do you think? What do we get?
It was Thomas Edison.
There you go. All
Yeah,
right.
my boy.
Flip that around. Pass them to Emily. All right. There you go.
Yeah.
He invented the phonograph, Tesla or Edison?
There you go. All right, Liam.
Despite being personally opposed to its use, what invention did Edison help fund in an attempt to discredit alternating current?
The electric chair.
Thinking?
Electric chair.
Electric chair. There you go. All right. Caitlin's got
Zappy
one.
seat.
Zappy seat. Yeah.
Who said it? I put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and
Awesome.
coal run out before we
Tesla.
tackle that. Edison.
Tesla?
Edison.
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 Yeah, Tesla.
Tesla.
Edison.
Tesla.
Who was it?
Thomas Edison.
Yeah. Okay. So way back in the day, man's talking about
Solar energy.
solar energy. Yep.
Alright, in 1876, Edison built his famous laboratory in Menlo Park. In which US state is Menlo Park?
Jersey.
New Jersey.
People know.
It's actually Florida. Nice.
Yes. I would believe it with the craziness going on. It very well could be. All right.
Florida.
Here you go.
Everything is Florida.
What is the name of Edison's motion picture invention?
Cat's boxing.
Cat's boxing.
Picture.
That was
What is it?
Phonograph.
All right, tell us.
Meowie.
a kinetoscope.
Oh,
Kinetoscope.
kinetoscope. Okay.
Kinetoscope.
His museum was funded by the cartoon The Oatmeal.
Okay.
True or false?
Tesla. It has to be Tesla.
Nikola Tesla.
There you go.
Yeah,
And
Tesla
our
has-
last one for today.
It had to be Tesla.
Yusuf.
This person, I already know this one. This person was born during a lightning storm.
Tesla.
Kanye West.
Who was it?
It was.
Tesla.
It's Tesla.
It was.
Okay, so one more thing about these two guys.
Oh my God, yeah.
One more thing about these two guys, just so you guys know. Both of them were to some degree homeschooled. Tesla early on, Edison kind of later. Edison went into school and had trouble doing,
At 10 years old.
yeah, he had trouble doing like basic math.
Oh,
The stuff that you guys are like, every time a lab involves math, he did not do well. And there's a whole legend. Yeah, there's a legend that he was sent home with a letter and his mother opened the letter and he said, "What does it say?" And she said, "Oh, they said you're too smart for this school. They can't do anything for you. You should be educated at home." And truly the letter said, "Your kid's an idiot and we don't want him here anymore." That's a legend. I don't even know how much truth is behind it, but it gets circulated. There's a meme about it, right? Now, neither of them, despite having their weird business practices, even Tesla, who seems oh so good and innocent by comparison, had issues. Tesla actually gambled away his college tuition. He had a gambling problem. And so, I mean, these guys, like, the two of them are fascinating by themselves, and they're more fascinating when you put them together. Like, they really had some crazy stuff going on in life. All right, so I know the lab said that you could turn one in, but we're not gonna turn one in. All right, we got Daddy here this week and it's just too hard. So you're gonna file it away
Homework.
in your binder. Homework's normal homework.
But it said we have to do something like the diagram.
Yes, there's a diagram. It should be it's in your binder. You'll see it in there, okay? So you'll do that and you'll turn that in. But it's homework like it's assigned. Does anybody have any questions about today? Are we good? All right. Excellent.
Is there any way we can see the cat's boxing thing?
I don't know if that exists, but let me look.
No.
Let me see if Cat's boxing is actually, let me end this first. End